name is Mr. Ademujimi Adelotu, the only son under the sun. We'll be looking at a topic called mensuration. What do I mean by mensuration? Mensuration deal with shapes. Deal with shapes. Deal with shapes. Either solid or plane. Either solid or plane. But what we'll be looking at today, we call it what? Plane figures or plane shapes. We're looking at plane figures, plane shapes or figures. Plane shapes or figures. Plane shapes or figures. Okay? We'll be looking at plane shapes or figures. What do I mean by plane shapes? Examples of plane shapes are circle, triangle, rectangle, square, kite, rhombus, and so on and so forth. These, what I've mentioned, they are what we call what? Plane shapes. But we'll be looking at the most important of those shapes today. Just one of it that is very, very what? Important, that is very, very common in JAMB, WAEC, POST-JAMB. Okay, many examples I want to write, very, very common, which is circle. Looking at circle. Circle. What do you mean by circle? Circle is a plane figure bounded by a curved line called circumference. Circle is a plane figure bounded by a curved line called what? Circumference. What do you mean by circumference? Circumference is the distance around what? Circle. Circumference is the distance that surrounds what? Circle. Let's take for instance that we have this. Okay? So this is circle. This is the circle. You can see that this circle is bounded by what? By a straight one, by a curved line. You can see by a curved line. So the curved line is what we call what? Circumference. So the circumference is the distance around this circle. So circumference could be this point, this point, this point. Any point on this circle is what we call what? Circumference. Circumference. And we have properties of circle. What are the properties? We have diameter, we have circle, we have diameter, we have radius, we have circumference, we have sector, we have chord, we have secant, we have tangent, and so on and so forth. Okay? So what do we mean by radius? Radius is a straight line drawn from the center of this circle to any point on the circumference. This is the center of the circle. So radius is a straight line drawn from the center. Any line drawn from the center, we can have radius in this form, it can be in this form, it can be in this form, it can also be in this form. So far the line is drawn from the center of the circle to any point on the circumference. The line is what we call what? Radius. Okay? We can also have radius in this form also. Okay? The second one is what we call diameter. Diameter is a straight line that divides circle into two equal segments. Or you check your textbook will say that diameter is a straight line that divides circle into two equal parts or into two equal halves. Whichever one you choose to pick. Okay? But diameter is a straight line that divides circle into two equal what? Segments. Diameter is also known as chord. Yes, let me justify that. You can call diameter chord. Of course, yes, because diameter is dividing it into what? Into segments. Into segments. And chord also divides circle into what? Into segments. But the difference between chord and diameter is this. Chord divides circle into two different segments, in which you have major segment and the minor segment. Are we together now? So when you are talking about, okay, this is a diameter. This is diameter, okay? So if you call this to be center C and we have AB, okay? So we can call A, C, B to be the what? The diameter. You can see, dividing this circle into two the same what? Segments. Into two equal segments and not two different segments now. Are we together? This is the first part, this is the second part, they are the same, okay? So this is what we call diameter. And we know that diameter is equals to 2 times r. 2 radii is diameter. That is 2 radii will give 1 diameter. that is radius plus radius, is equals to diameter. Meaning that from here to here is diameter. Take note. Diameter. Diameter. So, diameter. Diameter. That's D. Okay? So, from here we can say R is equal to diameter divided by 2. Okay? That is diameter divided by 2. We give what? Radius. Are we together? So, we have another part again that we call what? Chord. Chord. This is what we call chord. Chord is a what? Straight line that what? That runs from one part of the circle to another part, dividing the circle into two different segments, in which we have the major segment and the minor segment. Look at it here. Okay? Chord. You can see that. So this is the minor segment. Minor segment. Minor segment. This is the minor segment, while this is the major. This is the major segment, the minor segment. So what you have here is what we call what? Chord. Okay? Let's call this to be X, Y. So X, Y is what we call chord. Are we together? So this, the shaded part also, the shaded part is what we call segment. But this is called the minor segment, okay? This is what we call what? The segment, but known as the minor segment. We should say the same thing as the segment. But what do you mean by this segment? Segment also is a part of a circle. It's one of the properties, okay? Bounded by what? By a chord and what? Arc. Bounded by a chord with what? With arc. Bounded by a chord with what? With arc. We can try to what? Let's say this diagram is what is being drawn on the worksheet of paper, and we try to use scissors or what, or blade to trace out these parts. Look at what you're going to have there. We're going to have something like this. Can you see that? We're going to have something like this. We decide to trace that out. We're going to have something like this. This is chord. This is segment. So what can we now say now? That segment. This is what we call arc. Okay? What can we say from here now? The arc is equal to, the segment is equal to what? Arc plus what? Plus chord. It means that segment is made up of what? Two parts. The arc and the what? Chord. Are we together? Okay? So we have another one again that we call what? Sector. That we call sector. Sector is a part of a circle made up of what? Two radii and what? Arc. This is done by what? By sector. We have our circle here. We know that a line drawn from the center of a circle to any point on the circumference is called what? Radius. So this is the center of the circle. Let's call it to be center O. A line drawn from here to here, radius. From here to here, radius. We have A, B. Alright? So this is what we call arc. Is that also? So my teacher said that when two straight lines meet at a point, angle will be formed there. When you have two straight lines meeting at the point, there will be what? Formation of angle. So we have this is a straight line, another straight line meeting at this point. So there must be what? Formation of angle. So let's say we call this angle to be angle theta. Okay? So we can trace this out that OAB. So OAB is what we call sector. OAB is called what? Sector. This is the sector. We decide to what? To use our blade or scissors to what? To trace this part out. To trace out this part, we're going to have this. We're going to have this shape. We're going to have this shape. Decide to trace this out, we're going to have this shape. Something like this. Okay? Let's manage this. Something like this. If we trace this out, we're going to have something like this. Something like this. So this will be A, B, and this is O. Okay? And this is angle what? Theta. This is R, this is R. This is R, this is R. We have another one called tangent. We should not be looking at that because that is another part, although it is still part of it. It's a straight line drawn externally to a circle, which touches circle at the what? At the point. Which touches circle at the what? At the point. Which touches circle at the what? At the point. This is called tangent. 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 So it's a straight line drawn externally to a circle, which touches circle at the what? Point. PT. PT is the what? Tangent. It's called tangent. It's called tangent. Why this is called secant? This is called secant. You ask me, what's now the difference between secant and diameter? They are all the same. You can see that diameter is a straight line that divides into two of the same word segment. Of course, you can see secant only what touches the circle at how many points? 2 points. So they are not the same. Okay? And you can't call this chord. And it's different from tangent. Okay? Because tangent is drawn externally. Externally. Why secant? Secant is drawn internally. Okay, internally. So let's go to sector now. So we want to look at sector now. Sector. Let's look at sector. Sector now. Sector. So what do you mean by sector? I say sector is a part of the word circle, bounded by what? By radii and what? Chord. Bounded by what? Radii and what? And arc. Sorry, and arc. This is what we call arc. If you call this point to be C, so ACB. ACB. ACB is called what? It's an arc. The CB is called what? Arc. The CB is what we call arc. This is arc. Are we together now? So we're looking at our sector as a whole. So let's look at sector now. Sector. Okay? This is sector. Don't forget that where two straight lines meet at a point, angle will be what? Form there. So this is A and this is what? B. Radius. Are we together now? Okay? What are we looking at here? We get to look at the length of this arc. The length of this arc. The formula for finding the length of this arc, that is the distance of A from B. Okay? The length of this, that is the formula for finding the length of this, and the area of this sector. That is what we'll be looking at. But first of all, introduction. So let's look at the A part of it, the length of what? The length of this arc. The length of this arc. So let's call this to be L. Okay? So we can say length, the length of arc, the what? The L. Okay? Let's put the subscript A to show that we are talking about what? Arc there. So that's the length of arc A. Are we together? So we know that the length, you can say, length of arc A over what? Over what is the what? The angle at these points. Angle at the point is 360 degrees. Yes. Angle at the point is 360 degrees. That is 360 degrees. Okay? Equals to what are they? Equals to what are they? That's theta. That's theta times what? Times the area. The perimeter. That's the perimeter of what? The perimeter of this what? Perimeter of this circle. And what's the perimeter of the circle? Is 2 pi r. Of course. Don't forget that perimeter of circle, perimeter is equal to 2 pi r. Okay? Or pi d. Or you say pi d because this is r. Okay, from here now, what can we deduce from here? We can deduce that LA, okay, LA, the length over 2 pi r equals to the angle at the center, that is theta, over angle at point, that's 360 degrees. 360 degrees, that would be what? This is the same thing as the length of arc equals to What do I mean? That's theta over 360 degree times 2 pi r. In what? In centimeter. In centimeter. So this is the formula for finding what? Length of what? Length of an arc. Length of an arc is theta over 360 degree times 2 pi r in centimeter, and not in centimeter what? Square. Take note. Okay? Now let's move further. Let's move further now to the area. Finding what? The area of what? Of sector. What's area of sector? We can say let the area of sector to go to be A. So that will be AS. Let's talk about what? Sector. Area of sector over area. Okay? This is gotten from where? This is gotten from this circle. You know, we said sector is a part of a circle. Is a part of it. So area of a circle is pi r squared equals to the angle subtended at center, which is what? Theta over what? Over 360 degree. So from there we can have area of sector equals to theta over 360 degree times pi r squared in centimeter square. So this is the formula for finding what? Area of what? The sector. Are we together? Now let's move further to another aspect. We have looked at what? Diameter. We have looked at radius. We have looked at circumference of circle. That's the formula used for finding circumference of circle, or distance around circle. Still the same thing as circumference. When say circumference, talk about distance, okay? Talk about distance, which is given as 2 pi r, which is pi d, okay? Because you know that d is equal to 2r. Don't forget that, okay? Now let me circle this, just to know that it is not part of this. Are we together? Okay? Now let's look at chord. What do I mean by chord? Don't forget that I said that chord is a part of a circle, okay, that divides circle into what? Into two different what? Segments. Into two different segments in which you have major segment and what? Minor what? Minor segments. Okay? We have a circle. This is the chord. Are we together? This is the chord. We know that a line drawn from the center, this is the center of the circle. Let's call this to the center O. So a line drawn from the center to any point on the circumference is what we call radius. Another one, we call it to be radius. Is that also? So let's call this to be A, B. Of course, we know that this is what? Chord. This is called what? Chord. AB is called what? Chord. Line AB is called chord. Line AB is what we call chord. Please take notes. What can we deduce from there? Don't forget that I said when we have two straight lines meeting at a point, there will be what? An angle there. Angle will be formed. That is the rule. Okay? Now, if you produce a line, a perpendicular line, from where? From the center of a circle to bisect this triangle. This is a triangle. This is an isosceles triangle. Yes, this is an isosceles triangle. Why? Because this is R and this is R. R is equal to R. So two sides are equal. So it's an isosceles triangle. Okay? So divide it. Divide this. Okay? We are dividing it into what? Into two equal what? Parts. Okay? So a line drawn, there's a theorem that says that a line drawn from the center of a circle to bisect a chord is perpendicular to the chord. So when you have a line drawn from the center to bisect a chord, bisecting a chord to bisect this perpendicular. When you say something is perpendicular, that is at right angle. It's at right angle. That is, this perpendicular line is making the what? Is forming and 90 with the what? With the chord. So this is 90, this is 90 degree, of course you know. So let's call this perpendicular line to this point. Let's call this to be point D. Okay? Don't forget that we have bisected the what? The triangle. So this will be theta over 2. This also will be theta over 2. Yes or no? Yes. Of course you know that if you have the half plus this must be this, because looking for the LCM. LCM is 2. How many 2 can we see? 2. 1 times theta. Theta plus 2 into 1 times theta. Theta. Add the 2 together. That's 2 theta over 2. This and this will go. Yes or no? So we'll be left with theta. So that will be theta over 2. Theta over 2. Are we together? So from here to here is what we call what? The length of the chord. That's the length of the chord. That's length L. Since we are bisecting the triangle, or since we have bisected the triangle into 2 equal parts, it means that this part will be L over 2, L over 2. Yes or no? Yes. Because the theorem says, I will take this theorem again, a line drawn from the center of a circle to bisect a chord is perpendicular to the chord. To bisect means to divide. Okay? So dividing. So we're having that. So we can decide to pick any part that we want to pick. I can decide to pick this part or to pick this part. But I want to pick this part. Okay? So this is B, this is O, and don't forget that this part is D and not A. Take note. This is L over 2, this is R. And don't forget that this will be theta over 2. Is that also? Theta over 2. So this is 90 degrees. So this is a right angle triangle. But take note that this is not a right angle triangle. It is not a right angle triangle like this. I can prove it anywhere that this is not a right angle triangle. Why? Because the sign, there is no sign of a right angle here. But when you have this to it, what? This is a beautiful right angle triangle. Now let's go further by saying, using trig ratio, opposite of hypotenuse. Opposite of hypotenuse. Don't forget, you recall from your SOHCAHTOA. This is not trigonometric formula. No, this is just identities. The identities that we have in trig, but there are still more than this. With like cosine, tangent, and sine. We still have like cos, we have sine, and we have tang. Yes, a bit further. Okay, but let's just limit this for the sake of these studies. So I'm going to limit our scope to what? To this three only. Okay, so what do we mean by so? This is sine, this is sine, this is cosine, this is tangent. Okay, that is tan. Sine is opposite and hypotenuse, adjacent and hypotenuse, opposite and adjacent, opposite, hypotenuse, adjacent, hypotenuse, opposite. Hypotenuse means longest side. Check your dictionary. The longest side of the triangle is hypotenuse. So this is hypotenuse. So opposite over hypotenuse, meaning that we're talking about sine. Opposite over hypotenuse. Where this angle is facing, we serve as what? The hypotenuse, as the opposite. Just as I'm sitting down, you are facing the ball. So the ball will serve as your opposite. This is where you are facing. So where you are facing, that is your opposite. The northward side. Okay, this is the opposite of this angle, which you can say what? Opposite of hypotenuse. Opposite of hypotenuse. Opposite of hypotenuse. That is what? Sine. So you can say opposite of hypotenuse. That is sine theta over 2. Opposite of hypotenuse, that is sine theta over 2 equals to opposite, that will be L over 2. That is opposite. We handle this as a what? Single identity. Just single element. A single element. That's how we're going to handle this. Just the way we handle like Y or like X. So we're handling this one like a single one identity. So in brackets you can see over, because it's opposite of hypotenuse, over half. Are we together? So from here, we can have this as over 1. You cross multiply. So we can have r times sine what? Sine theta over 2. Sine theta over 2 equals to L over what? Over 2. Please don't be what? Tempted by saying that these two will multiply this. Because these two now serve as what? Angle. The 2 here now, because theta over 2, they are together. You can't split them. You can't. You can't split them. Okay? Now look at this now. So from here we can have L over 2 equals to R sine what? Sine theta over 2. Are we together? So we should see the same thing as L equals to 2R sine theta over 2. So this is what? The formula for finding length of what? Length of the chord. So if you are asked to find length of the chord, this is the formula to you. 2R sine theta over 2. In what? In centimeter. In centimeter. And let's just look at 2 examples. Just one example that will cover all what we have been proving since morning. Now let's go there. Let's go there. We are getting there. Okay? We are getting there. Now let's go. Example 1. Example 1. Alright. We have this. From the diagram above, or from the fig shown above, find A. Find A. Length of the arc. Length of the arc. B. Area over sector. C. Perimeter. Let me have this. Perimeter of sector. D. Length of the chord. What? Very simple. Very simple. So we're going to what? We are applying all the formulas. The first one there is length of what? Arc. What's formula for finding length of arc? LA equals to theta over 360 degree times 2 pi r in centimeter square. So we have to note. Leave your answer in terms of pi. So our answer must be in terms of pi. Okay, equals what's theta? Theta is 90 degree. That's 90 over 360 degree times 2 pi times r. R is the radius. That's 7. Okay, 90 here 1. 90 in this is 4. Because 9 times 4 is 36. Okay, 2 here, 2 here 1. And that gives what? 7 pi. That is 7 pi over what? Over 2. In what? In centimeter. So that will be 7 over 2 centimeter. So that's the answer. The second one. You can pause the video and try it. So you can always pause the video. Try. So let's look at the second part of it. That's B. A. B now. B is area of the sector. We know that. Recall. That's the name of my friend. Area of the sector equals to theta over 360 degree times pi r squared. Okay? Take notes. That's the formula for finding area. Area pi r squared. So that would be 90 over what? 360 times pi. Your answer must be in terms of pi. Pi times 7 squared. That would be 90 over, okay, let's cut everything. 1, that's 4. 1 over 4 times pi times 49. And that will give us what? 49. See the same thing as number 1. 49 times pi times 1. That's 49 pi over 4. 49 pi over 4. Okay? Centimeter what? Centimeter squared. Okay? You can still leave it in what? In the form of mixed fraction, if you like. Okay? So let's move to the same part. That's part C. What are we asked to find? Perimeter. What do you mean by perimeter of this? When you are saying perimeter, perimeter of the sector. Perimeter of the sector means what? The total distance that around this sector. The total distance that around this sector. If you look at the sector now, if you look at this, look at the sector. We have radius, we have this. We have length of all the arc. So the perimeter P will be equal to R plus L. L is the length of what? The arc. So what's R? 7 plus 7 plus length of the arc. What's the length of the arc? It's 7 pi. That's 7 pi over what? Over 2. 7 plus 7. That's 14. 14 times 2. That's what? 28. 28 plus 7 pi over 2 centimeter. That's the perimeter. How do you get that? Let me break it down. Look at it. 7 plus 7, that's 14. Plus what? 7 pi over 2. Look for the LCM. The LCM is 2. How much can you say 2? 2 times 6, 28. Plus 2 into 1 times 3, that is 7 pi. You can't add this and this together, okay? Unless you combine the pi. And don't forget that we have to leave the answer in terms of pi. So the last part, the last but not the least, you can always pause the video and try. So what are we asked to find? Length of the cord. What will be the formula for finding length of the cord? Just use the formula straight away. That's all. So that will be 2. We know that. Recall, length of what chord equals to sine theta over 2. What? Yes. That's what 2 times R is 7. Radius is what? Radius is 7. Times sine 90 degree over 2. And that gives what? 14 sine what? Sine 45 degree. What is sine 45 degree? Let me just take you through this. Okay, we know that this is root 2, 1, 1. This is, okay. This is 45. Opposite over hypotenuse, that will be 14 times 1 over root 2. Because normally, that will be 14 over root 2. Normally in mathematics, our answer must not be in short form. So we rationalize it. That's times root 2 over root 2. And that will give you what? 14 root 2 over what? 2 root 2 times 3. Now root 2 times root 2, that's 2 centimeters. That's the final answer. Thank you and God bless you.